students, welcome to Mahila Samaj online class. So once again I am here to teach you 9th standard mathematics. In this, so we are going to continue the class of triangles. Okay, so triangles, in last class we have studied about the meaning of triangles, example for the triangles, so and criteria for congruence. So we have studied in that SAS, ASA, SSS and RHS postulates and its corresponding problems based on the postulates we have studied. Now in this class we are going to study about one of the important property which is based on the isosceles triangle. Okay students, so what is meant by isosceles triangle, dear students? So here isosceles triangle means, so the triangle which is having two sides are equal in its measurement. Such a type of triangle is called as a isosceles triangle. So once again dear students, isosceles triangles means two sides or of a triangle is equal in its measurements. That is called as isosceles triangles. Two sides of the triangle are equal in measurements. So that is called as a isosceles triangle. Okay, so for example, let us observe here this diagram. So this is PQR. This is the side, this is another side. So these two sides are equal in measurements. For example, it is 5 centimeter. This is 5 centimeter. This is about 6 centimeter. Okay, so in this triangle, side PQ is equal to side PR, because these two sides are measuring same measurement. Okay, that is equal to 5 centimeter. If two sides are equal, then triangle PQR is isosceles triangle. Okay friends, so can you observe this? Isosceles triangles means two sides of the triangle are equal in its measurement. That is called as a isosceles triangle. In this diagram, PQ is equal to PR. Okay, so hence PQR is an isosceles triangle. From this triangle, so we are going to take a special important theorem. So what it is, basically this is the side, this is the equal side. So in between these sides, some of the angles which is formed here. So see, this angle is opposite to this PR. So for this side PQ, the angle which is opposite here. Okay, so again angle Q and angle R is formed. Okay, with respect to equal sides, that is PQ is equal to PR. Some of the relationship which are made for these two, that is what we are going to study now. That is a special theorem that is called as a theorem. We are going to study on the isosceles triangle here. Relations between equal sides. Okay, so in this we have a statement for this, that is the angles statement angles opposite to equal sides of an isosceles triangle are equal. Okay, so what I told previously, so that is the thing. So for that, from that, so we have made the statement: the angles opposite to the equal sides of an isosceles triangle are equal ಅಂತ. So two equal sides ಗೆ opposite ಅಲ್ಲಿ ಇರುವಂತ two angles ಕೂಡ ಏನಾಗಿರ್ತವೆ, ಅವು ಕೂಡ equal ಅಂತ ಹೇಳ್ತಾರೆ. So this is the statement. So from this statement, so we should carefully read 2 or 3 times this statement, something what given. So what we are going to prove. So it means, so every statement of the mathematics, it should be containing two parts. One is what is given. So what we are going to do. So let us study let us read one more time this statement. The angles opposite to equal sides of an isosceles triangle are equal. ಅಲ್ಲಿಗೆ so two sides of an isosceles triangle two equal sides ಅಂತದೆ. So let us draw a diagram first. So we want to draw a isosceles triangle here. So this is A, B, C, ABC ಅಲ್ಲಿ. So AB and AC are the two equal sides. Okay, from this, okay, so let us collect the data. What is given? That is about data. Theorem, if you want to prove any theorem, it is always containing 4 steps. That is data, first step, to prove, next construction and proof. Okay students, so if you want to prove any theorem, so it should be containing these 4 steps. So let us study first one. So that is step 1, that is data. You can take here. So what is data? Data means what is given in the statement. I already told. So ABC is a isosceles triangle. Correct? Yes, they are given in the statement. Okay, so right now, next, in this isosceles triangle means AB, side AB is equal to side AC. It is given side AB is equal to side AC. Okay, this is given in the half of the statement. So next half of the statement, to prove, what we are going to prove here, this equal sides ಗೆ opposite ಇರೋ two angles ಏನಾಗಿರುತ್ತೆ, equal ಅಂತದೆ. Which is our angle? See here, this is AB, its opposite angle is C. So this is AC, its opposite angle is B. Okay, this is angle opposite to AC. This is angle C, which is opposite to side AB. Okay, so we want to prove here angle B is equal to angle C. Okay students, so this is what we are going to prove. So it means always the statement which is containing two parts, data as well as a proof, to prove. Okay, so in this ABC is a isosceles triangle where AB is equal to AC. See, this is a ABC triangle. So AB is equal to AC. These two sides are equal, hence it is isosceles triangle. So we want to prove. So this is angle C, which is opposite to side AB. So this is angle B, which is opposite to side AC. Okay, so for this we should make a small construction in the diagram. Construction. So let us take angle bisector of angle A in the triangle ABC. Okay, that is made a point on BC. Okay, so that is the construction what we made. Just you can write down here. So it means, so angle bisector of angle A and point D on BC. Okay, side BC. So this is construction what we made here. So next, last step, proof. Okay, from the diagram, let us observe here. So we want to take here these two triangles. It's a triangle. So if you want to prove the congruence or a similar, we need pair of triangles I already explained in the last class. Okay, so here we have two triangles. Take the two triangles from triangle ABD and triangle ADC. Correct. Right. So next here, comparison of these two triangles, it should be indicating something, information should be giving. Is it right? So let us see here. So what it is giving? First AB. Side AB is equal to side AC. So this is already given because of these two sides are equal in triangle ABC. ABC is an isosceles triangle, hence AB is equal to AC. Okay. So next angle BAD. See here, angle BAD, this one is equal to angle DAC. Angle. Okay. So DAC. So this is by construction. Angle bisector, or it is angle bisector. Is it correct? Right. So next, so we want to take here now here AD. What is this AD? Is equal to AD only. So this is a common side. Common side, correct? So from this, so this is side, this is angle, this is side. So by SAS triangle ABD is congruent to triangle ADC. Correct, students? Yes. Now next here, by this we shall take angle ABD is equal to angle ACD. Right? So by CPCT, corresponding parts of congruent triangle. Correct. So angle B is equal to angle C. So this is your proof. Correct, students? So once again, let us observe here. This statement of the theorem is the angles opposite to the equal sides of an isosceles triangle are equal. So from this, so you have to take the diagram ABC as a isosceles triangle. ABC as a isosceles triangle where AB is equal to AC. Okay. So next what we are going to prove. So take angle C is opposite angle of side AB and take angle B as opposite to the side AC. This is the equal sides, is it right? So angle B is equal to angle C, what we are going to prove in this theorem. Okay, so for that you should make a small changes in the diagram, that is construction. Angle bisector of A and D point on BC. Okay, so from the we want to take the proof here from the triangle ABD and ADC. You should have to make comparison here. Side AP is equal to side AC. Okay, this is given from the data or in the statement. Okay, so next BAD and DAC, these two sides if you take by a construction or angle bisector. Okay, so next AD is equal to AD only. Okay, it is a common side for both the triangles. So by this, so by SAS congruence rule, so these two triangles are congruent. Okay, so due to that ABD and ACD are the corresponding parts of congruent triangles. Due to that angle B is equal to angle C. This is the proof for, so angles opposite to equal sides of isosceles triangle are equal. Okay, students. So from this, based on this result, some of the problems we are going to do this. Okay, right. So this is very important theorem, dear students. Please practice well this one, because of if you want to do more problems as well as expanded theorems, so based on this it is very helpful for your further level of the education. This is just basic ideas, just what we are studying the congruence rules or criteria for the congruence of a triangles. Okay, so based on this, we want to take the problem here. In a triangle ABC, first problem, in a triangle ABC, the bisector AD of angle A is perpendicular to side BC. Then show that AB is equal to BC. AB is equal to BC, and triangle ABC is isosceles. Okay, students. So this is the problem. So we want to take here. Okay. All right. So this is not BC. This is AC. Okay. So for this, just ABC, we can draw a diagram here. This is ABC triangle. This is ABC. Okay. So AD is perpendicular. It means, so from here, this is perpendicular. Okay, this is a point D on BC. Right. So now from this, we want to prove here AB is equal to AC first. Then after that, you can show that ABC is a isosceles triangle. Okay, friends. So from the diagram, from the figure, triangle ABD and triangle ADC. Okay. So from this, just we can take the comparison points. So what we are going to compare here? Just with any objects, if you take angles and sides, you should have to make a comparison. Okay, friends. Right. So next, BAD, side BAD is equal to DAC, angle DAC. Why it is? Because of this is the angle bisector, the line which is perpendicular from the BC. Okay, right. So next, so side AD is equal to side AD. Correct? Right. So this is bisector. So this is common side. So next, you want to take this one, angle ADB. Angle ADB is equal to angle ADC. This is perpendicular. It means 90 degree. Okay, this is perpendicular. So now here, this is ASA by ASA, triangle ABD is congruent to triangle ADC. Correct, as friends? Yes. So now just take now side AB is equal to side AC. Why it is? Because CPCT, it means corresponding points of congruent triangle. Okay. So if two sides are equal, if two sides of a triangle of the triangle is equal, then ABC is a isosceles triangle. Okay students, so this is about this problem. Okay, so next we want to take one more problem here. Next, one more problem. This is a problem which is based on this theorem. The angles which is opposite to the equal sides of an isosceles triangle is equal. Okay, based on this problems we are doing here. Now next problem it is problem number 2. In an isosceles triangle ABC with AB is equal to AC, comma D and E are the points on BC such that BE is equal to CD. Then show that AD is equal to side AE. Okay students, so this is about your problem. For this, just you should draw a diagram here. So this is isosceles triangle ABC. This is A, B, C. Next, we want to take 2 points on BC, D and E. Just join with A. Okay, so AC is equal to AB. So then you can prove that AD is equal to AE from this diagram. Okay, so for this, so just take the solution. For this we have a solution here. So now we can take the triangle here, that is triangle ABD, from the triangle ABD and triangle AEC. You should take these 2 triangles to make the comparison. So here AB is equal to AC, correct, already given in this, because ABC is a isosceles triangle. Due to that one, so they are given this, right? So next, angle ABC, it means angle ABC is equal to angle ACE. So you should take D. Okay, so this is ACE. Why it is equal, dear students? So angles opposite to equal sides, correct? Yes. So next we want to take here BE is equal to CD. That is already given in the data. Okay, given. Okay students, so from this what you are observing, so ABD is congruent to AEC, right? Triangle AEC. So but what we are going to prove here, AD is equal to AE, just we should show, right? So for this, just you should take BE. So how to write BE? BE means, so this BE can be rewrite as that is we want to take here BD. We want to take BD. So this BE, andre, so it should become this is BE minus DE. BE minus DE is equal to, just CD also you can rewrite, that is CD minus DE. Okay, so from the diagram, just observe the diagram. This is BE, we can make a minus of DE to get BD, right? So here also, so this is CD minus DE, you want to get here, this is CE, right? So just observe here, BE minus DE is, this is BD, right, is equal to, this is CE, right? What is this? Equals or subtracted from equals, one of your axiom of the Euclid is a triangle. So then BD, side BD is equal to side DE. So due to that, triangle ABD is congruent to triangle AEC. Correct, students? So due to that, so this BD matte DE, what it is, that is CPCT ಅಂತಲೂ ಹೇಳ್ಬೋದು, right? Corresponding parts of congruent triangles. Okay, so now here just you can take these two here, this is AD. If these two triangles are congruent, then you can take AD, side AD is equal to side AE. Okay, so these two are CPCT. It means corresponding parts of congruent triangles. Okay, students. So once again, this problem, in an isosceles triangle ABC with AB is equal to AC, because of these two sides are equal, then the D and E are the points on BC such that BE is equal to CD. BE is equal to CD. So now show that AD is equal to AE. From this diagram, triangle ABD, just comparison with AEC. So AB is equal to AC. This is the parts of isosceles triangle. So next angle ABD and angle ACE, these two triangles are equal because of angles opposite to equal sides are equal. So due to that one, so these two sides are equal. Then BE is equal to CD. It is already given. So now next this BE can be rewrite as BE minus DE, then CD minus DE. Okay, so equals are subtracted from the equals, then it can BD is equal to DE. Okay, BD is equal to, sorry, it is CE. Okay, now next here, so triangle ABC, triangle ABD congruent to triangle AEC. So due to that, so this is AD is equal to AE, or the corresponding parts of congruent triangles. Okay, students. So next, one more problem for this. So ABC is an isosceles triangle. ABC is a isosceles triangle in which BE and CF are the altitudes are drawn equal sides AC and AB, then show that altitudes are equal. Okay, so this is about your problem. Okay, from this just we can take the isosceles triangle, that is ABC. So AB is equal to AC is already given. So then you can draw a altitudes BE. BE. This is E. So this is CF. F. Okay, students. So this is about your diagram. So now you can take here from the diagram, from the triangles BEC. Sorry, BEC. Triangle BEC and triangle BEC and BFC. Okay, so let us take these two triangles in the comparison. So what it is indicating, just you can take angle B is equal to angle C, correct? So angles opposite to equal sides, right? From that itself already it should be indicating that isosceles triangle AC and AB are the two equal sides. So angles which is opposite to corresponding sides, it is equal, right? So next, side BC, here side BC from BEC as well as a BFC. So these two sides are equal. It means common side for both the triangles. Common side, right? So next, if you take angle here BFCLE, angle F or angle E is equal to angle F, correct? So that is equal to 90 degree. 90 degree. All right angles are equal. All right angles are equal from the axis. Okay, so from this, so this is angle, this is side, this is angle by ASA congruence rule. Triangle BEC is congruent to triangle BFC, right? So from these two, let us take your BE, side BE is equal to side CF. Okay, what about this? This is corresponding parts of congruent triangles. Okay, students, so this is about your proof. Okay, so once again, ABC is isosceles triangle in which BE and CF are the altitudes drawn to equal sides AC and AB. Then show that altitudes are equal. Okay, so from this diagram, just you can take two triangles BEC as well as a triangle BFC. So in this, angle B is equal to angle C. Angles which is opposite to the equal sides. There is a reason, that is that. Okay, angle BC, side BC is equal to side BC. It is side BC from both the triangles. It is equal. It means common sides. So angle E is equal to angle F. It is 90 degree. All right angles are equal. By ASA postulate or ASA congruence rule, triangle BEC is congruent to triangle BFC. Due to that, so these two triangles are congruent. Then its corresponding parts BE is equal to CF. Right, students? So this much information we want to share in this class. So more about in this class. Next class we want to share more about the triangles. Thank you, students.